A remarkable revelation made by the James Webb Space Telescope has uncovered what appeared to be city lights in space, discovered 7 trillion miles from Earth. This extraordinary finding has sparked interest in the potential for extraterrestrial life. The telescope focused on Proxima Centauri b, the nearest exoplanet to Earth, revealing unusual bright lights emanating from it. What might be causing these city lights on Proxima Centauri b? Could this indicate the existence of life beyond our planet? Join us as we explore how the James Webb Space Telescope identified these unprecedented phenomena in space. For years, scientists and the public have speculated about the possibility of life beyond our solar system. Any evidence supporting this aspiration of space exploration has been met with excitement. Recently, mainstream scientists were stunned when the James Webb Space Telescope detected strong signs of life in space. While studying the cosmos and transmitting data back to Earth, the telescope spotted strange city-like lights flashing from the exoplanet Proxima Centauri b. These lights, as their name implies, seemed to illuminate a distant metropolis. The possibility of an alien city existing on this star has left researchers astounded, as it could be the breakthrough they've long hoped for. If this turns out to be true, as many believe it might, it would suggest the presence of intelligent life, forms constructing civilizations far beyond human comprehension. We are just beginning to find them. 7 of these city lights were examined, 7 trillion miles from Earth. NASA engineers are left wondering how long these lights have been shining in space, waiting for humanity to develop the technology necessary to detect them. David Kipping, an expert from Columbia University, describes the Proxima b exoplanet, where the city lights were discovered, as fascinating. He notes that this star system, the closest to us, has varying warming patterns that differ from those of other planets. While typical rocky planets are known to absorb sunlight and emit infrared radiation, Proxima b's infrared emissions differ significantly from its host star, Proxima Centauri. This suggests an intriguing characteristic. The James Webb Space Telescope, JWST, which can detect infrared frequencies, has uncovered a singular heat signature of Proxima b that plays a key role in unlocking the mysteries of its atmosphere, thanks to its cutting-edge infrared imaging capabilities. The JWST will be utilized by researchers to delve into the planet's atmospheric secrets. It is expected to help assess the potential for life on this exoplanet. The JWST's infrared sensitivity enables it to study what occurs on Proxima b's night side, capturing even the faintest beams of light in the vast darkness. While this has traditionally been a challenge for space telescopes, the JWST excels at detecting even the smallest emissions from space, making it the ideal tool to verify if the rumors of city lights on Proxima b's night side are true. Any artificial lighting in the universe can be identified by the telescope, provided it falls within a frequency band 1,000 times smaller than starlight. Proxima b has a fascinating relationship between its celestial components and surface features. The exoplanet's day side is home to numerous solar panels that capture the radiant energy from its star. Its spectral edge also reflects incoming light. As Proxima b completes its orbit around its host star, Proxima Centauri, it experiences both day and night periods, similar to Earth's. During the day, it encounters intense solar heat, while at night, the planet cools down. Known for fluctuating temperatures, Proxima b's composition plays a crucial role in determining its climate. If the planet lacks an atmosphere, the temperature difference between day and night will be extreme. Without atmospheric gases to moderate the temperature, the day side will be scorching hot, while the night side will plunge into freezing darkness. The extent of this temperature variation is a crucial subject for astronomers to investigate, as it provides valuable insights into Proxima b's atmospheric composition. Using the JWST's unrivaled infrared imaging capabilities, scientists will be able to analyze the planet's thermal emissions in greater detail, gaining access to crucial information about its atmospheric properties. Interestingly, the JWST's orbit around Earth aligns with Proxima B's orbital period, allowing for thorough observations of its day and night cycles in just 11.2 Earth days. Since Proxima B is believed to have an atmosphere, the next step will be to examine its atmospheric chemistry to determine its potential to support life. Key indicators of life include the presence of gases like water vapor, oxygen, and methane. If these elements are discovered, it would suggest habitable conditions. The process of capturing and analyzing light passing through the planet's atmosphere will be difficult, even for the JWST, because of its constrained capabilities in observing distant exoplanets. Despite these limitations, astronomers are looking forward to the arrival of ground-based observatories like the Extremely Large Telescope, ELT, which is expected to operate in 2028. The ELT will be capable of probing the atmospheric structure of more distant exoplanets, providing essential data on their habitability. NASA researchers and the general public eagerly anticipate the development of future space telescopes, but the JWST remains, for now, a vital tool in our quest to understand the mysteries of distant exoplanets. Although powerful, the JWST has its constraints and can only study a limited number of nearby exoplanets. For more extensive examinations of the atmosphere, scientists are relying on future telescopes and ground-based observatories, such as the ELT. These instruments will work together to enable comprehensive research on distant worlds. Researchers are also looking to future telescopes to reduce the amount of bright light from a planet's host star, improving the ability to detect faint reflections of light from the exoplanet itself. Using devices like inner masks or large external satellites, scientists aim to block out the harsh brilliance of the host star, much like shielding the sun with your hand to better see a distant object. This technique will allow telescopes to focus more effectively on the exoplanet, providing clearer data on its atmosphere and potential for life. However, this approach presents challenges, as astronomers will need to differentiate between gases produced by life forms and those created by geological processes, such as volcanic activity. Despite the challenges, astronomers are determined to enhance our understanding of exoplanets, to identify signs of life beneath the surface, and distinguish them from potential JWST false positives. This represents a glimpse into the future of scientific advancement in exoplanet research, offering a preview of the amazing discoveries that are yet to come as we continue to explore the universe. Despite the fact that no exoplanet has yet definitively been demonstrated to contain life, the search continues. Are we alone in the universe? For centuries, individuals have wondered whether they are the only intelligent beings in existence. This age-old question persists, and the search for extraterrestrial life is ongoing. In 1984, Jill Tarter and Thomas Pearson, two American astronomers, launched a project called the Search for Extraterrestrial Intelligence, SETI, which remains active today. Through this non-profit initiative, they have worked to analyze radio transmissions from space, as radio signals are better suited for long-distance travel without being scattered or absorbed. Despite over 30 years of monitoring signals from space utilizing radio telescopes, no conclusive alien signals have been detected. However, Jill Tarter remains optimistic about the potential of the James Webb Space Telescope in this quest for extraterrestrial intelligence. Launched in December 2021, the James Webb Space Telescope, JWST, is regarded as the most advanced infrared imaging telescope ever created. It is equipped with cutting-edge optical technology designed to peer through cosmic dust, uncover the secrets of the universe. The primary mission of the JWST is to investigate the universe, looking for the very first galaxies and stars that formed billions of years ago. With its state-of-the-art instruments, including a near-infrared camera, a mid-infrared instrument, and a fine guidance sensor, the telescope is equipped to capture faint light from distant objects and maintain its precise position in space. Since its launch, the JWST has produced incredible images and sent back groundbreaking data, offering new insights into the universe. While its focus has primarily been on exoplanets, galaxies, and distant stars, the unexpected discovery of city lights in space has led scientists to reassess the possibility of life on other planets. Proximus's discovery of city lights has taken researchers aback by Centauri B. The investigation continues. The JWST's unparalleled capacity for exploring the farthest reaches of space has brought humanity closer to answering one of the most profound questions of all. Are we alone in the universe? As scientists continue their research on the enigmatic city lights of Proximus and Centauri B, the next steps in understanding life on other planets are replete with intriguing possibilities. Whether these lights are artificial or the result of a natural phenomenon remains uncertain. Some scientists speculate that these lights could be an indication of advanced civilizations, while others believe they may be bioluminescent organisms that produce artificial light. In either case, the potential for artificial lighting from such a distant exoplanet challenges our understanding of life's limits in the universe. As the search for extraterrestrial life continues, the discovery of city lights on Proximus and Centauri B has opened a new avenue for scientific investigation. The next phase of research will involve close monitoring of the light emissions from Proxima Centauri B. By carefully studying the variations in these emissions over time, scientists hope to determine whether they follow patterns that suggest artificial origins, such as those produced by power grids or other technological infrastructure. Such long-term observations will be crucial, as they may reveal more about the nature of these lights and whether they are the result of intelligent life forms or an unknown natural phenomenon. In addition to tracking these light emissions, researchers will continue to investigate the atmospheric conditions on Proximus and Centauri B. The interactions between the exoplanet's atmosphere, its host star, and its magnetic fields could all play a role in generating visual effects that appear as city lights to the JWST sensors. These unique atmospheric processes are still a point of debate among experts, and more data will be needed to confirm or refute the possibility of a fabricated source. The JWST's ability to observe Proxima Centauri B consistently will be key in answering these critical questions. As technology progresses, scientists will develop even more advanced tools to help analyze distant exoplanets. Future space telescopes and ground-based observatories, such as the Extremely Large Telescope, will provide enhanced capabilities to detect faint signals and gather data that the JWST alone may not be able to achieve. These new instruments will form a collaborative network, enabling astronomers to focus on exoplanets more deeply than ever before. Together, they will advance our understanding of the universe and bring us closer to confirming the presence of life beyond Earth. The search for intelligent life on distant worlds has taken a major step forward with the discovery of city lights on Proxima Centauri B. While the idea of extraterrestrial civilizations remains speculative, every discovery, whether it's a faint signal, strange light emission, or an unexplained phenomenon, brings us one step closer to answering the question, are we alone in the universe? If future research confirms the existence of intelligent life, it could initiate a new chapter in human history. The potential for knowledge exchange, cultural enrichment, and even technological advancements could transform life on Earth in ways we can't yet imagine. However, even if no clear signs of alien life are discovered, the journey of scientific inquiry itself holds tremendous value. Each step forward in our understanding of distant worlds adds to the grand narrative of humanity's quest to explore the cosmos and uncover its many mysteries. The consequences of discovering extraterrestrial life are profound, not just for science, but for philosophy, society, and our collective sense of position in the universe. Recognizing that we are not alone could reshape our worldview, challenging our ideas about life, intelligence, and our role in the vast expanse of the cosmos. It could prompt a re-evaluation of what it means to be human and inspire new collaborations across nations and disciplines to understand and connect with other intelligent civilizations, should they exist. Until then, the search continues, motivated by wonder and curiosity as humanity looks to the stars for answers. As researchers at NASA and other space agencies continue to study the data from the James Webb Space Telescope, they remain hopeful that this mission will help us uncover the secrets of the universe and unlock the greatest mysteries of existence. Whether or not we find signs of life, each discovery brings us closer to the ultimate goal of understanding our place in the cosmos and the potential for life beyond our planet. In the years ahead, the advancement of space exploration will carry on with new technologies, telescopes, and more ambitious missions that will expand our knowledge and allow us to observe distant exoplanets in greater detail. These efforts will pave the way for groundbreaking discoveries that could forever change our comprehension of the cosmos and our relationship to it. Whether it's the research of extraterrestrial cities, the strange light emissions, or the investigation of distant worlds for signs of habitability, the journey to uncover the truth about life beyond Earth is just beginning.